Hi, everybody. Let's get started. I know people are still trickling in. The registration process slows the people down a little bit, but I'll tell you why we have a registration process. So welcome to this month's Rollins Grand Round Lecture. I'm Yang Liu, Professor and Chair of the Gang Rosa Department of Environmental Health and Director of the Emory Climate and Health Actionable Research and Translation Center, or CHART. It's my great pleasure to introduce today's lecturer. Dr. Drew Shindell is Nicholas Professor of Earth Science at the Nicholas School of the Environment at Duke University. Dr. Shindell's research focuses on the consequences of policies to mitigate climate change or improve air quality. These include impacts on human health, agricultural yields, climate, and the economy. Dr. Shindell is a world-renowned climate scientist. He's an author of more than 300 peer-reviewed publications, a fellow of the American Geophysical Union and the AAAS. He's testified before both U.S. Senate and the House of Representatives and made numerous media appearances. He was a coordinating lead author of the IPCC 2013 AR5 report and the 2018 IPCC special report on the 1.5 degree global warming, and chaired the 2021 Global Methane Assessment for UNEP and the Climate and Clean Air Coalition. He serves on the Science Advisory Board of the US EPA. He was elected to the US National Academy of Sciences in 2023. He is also a member of CHART's External Advisory Board. So this event is co-sponsored, it's mostly organized by the Dean's Office and co-sponsored by the CHART Center. The registration is part of the program evaluation that's a key component of our center. We'd like to build a listserv, a community, to disseminate our findings, news, and opportunities. Okay, so thank you for taking the trouble. Your trouble is not over yet. At the very end of Drew's presentation, there is a survey. There's going to be a QR code on that slide. Take a picture of it. It's going to lead you to a short survey designed by CHART's lead program evaluator, Dr. Nikki Ryder, to get some feedback about how we organize similar events like this. Okay, so thank you very much. Please join me to welcome Dr. Shindell.
Okay, great. Hopefully you can all hear me. Thank you, Yang, for that nice introduction, and thank you, everybody, for inviting me here. It's my first visit to Emory, and glad to be here and happy to be part of the advisory group for this new center. I'm looking forward to working together. So I'm going to hopefully go rather quickly, which doesn't sound like an ideal thing to aim for, but quickly in order to leave time for questions at the end and not get bogged down in my own discussion too much. But I wanted to talk to you today about some of the work that we've been doing over the past several years to look at both effects of heat exposure and air pollution exposure. And I want to set a little bit of a background by saying some things that probably everybody knows, but just to kind of put a little context in place about a couple things here, right? We talk about climate change as such an important thing, and I think people really have changed over the past couple decades, and people recognize now that it's an important thing, and we see it happening, and the data is unambiguous there on the left. We passed 1.2 in the 5-year average, and last year, as the right panel shows, right, we're pretty darn close to 1.5, which we all pledged at the Paris Agreement, we'd aim towards limiting temperatures, right? So we're not doing it. We are recognizing that now it's important, and people go out in the streets sometimes even and say we need to do stuff, but in practice, we're still acting far too slow. And so there are reasons, of course, that we act far too slow, not least amongst them, right, here's an analysis of the last 50 years, where the average, there's a lot of variability in the fossil fuel markets, but the average income is $1 trillion per year from this industry, right? In a peer-reviewed paper. So if you think about what that translates to, right? let's say that industry figures, oh, let's spend 1 day of profit per year trying to maybe slow down action. Or that's a lot of money, right? Or let's say the people that work in this industry think, I don't want to change what supports my family, and I don't want to do something different. Let's do this, but let's postpone for a while. And that's essentially what's going on. We are dragging our feet very slowly towards a reduction of fossil fuel use. And the IEA projects this will happen. Everybody thinks this will happen, but it's happening much too slowly. And there's good economic rationale for it to happen slowly. People are giving up a lot when they phase out fossil fuels. And so I think we need to recognize that it's not because people don't necessarily accept the science or don't even accept the need, but there's a lot of incentive to transition slowly. What makes it really challenging in many ways is that this comes from some work we did a couple years ago where we were trying to look at the discussion of how quickly you really get a dividend from acting on climate change. And one of the tricks is the biggest source of CO2 emissions is, or at least the worst source in terms of CO2 per unit energy generated, is burning coal. So we have to get rid of the coal because that's the dirtiest of all the fossil fuels. But coal also produces a lot of sulfur. And that sulfur is a cooling aerosol. It's bad for people that breathe, as I'm sure everybody here knows. But that means that you're taking that out at the same time. And so if you look at 30 years from when measures might be implemented, your average across all of these different scenarios and different climate sensitivity estimates is about 0, right? You get a great benefit in the long term, but you really have to wait decades to see the fruit of your action in terms of mitigating climate change. And that's a tricky thing, right? When you're saying people, you should forego $3 billion a day for the sake of something where you won't actually see an improvement for 3 decades. We've had a lot of analyses on the economics of climate change. Here's one of the examples from 2015 from the OECD, where they were trying to refute the argument that, some places actually will come out ahead, even though other places will come out worse. And at the time, there was a lot of discussion, maybe it's not so bad for Canada, it's pretty far north, things like that. What they concluded was that it would be worse everywhere to have climate change continue to advance without additional mitigation. And echoing the Stern review from a little bit beforehand, doing nothing will cost more than acting, right? And so this is pretty well accepted in the climate community. But what's really accepted here is that doing nothing will eventually cost more, right? Doing nothing will eventually cost more than acting. And the acting is now. And if you look out here, for example, 30 years after this one has intervention starting in 2010, right? You're down at these tiny little couple tenths of a point of GDP. And this is the total impacts. This isn't even necessarily what you can avert by acting, right? Because when you act, you don't really bend the curve in the first 30 years. So what you can do is start to shave off some of the damages in the long term. It's a little bit higher in some regions of the world, right? But even on average, it's pretty small. So you're asking people to make a big change now for the sake of something that will happen later. Right? And as if that wasn't a hard enough argument to make, there are additional arguments that get thrown out in the wider discourse as soon as we start to try to advocate for actions now, right? Which really emphasize the cost, this part. Doing nothing will cost more than acting. Doing nothing and seeing damages in the distant future is hard to conceptualize. There are a lot of groups that try to make real what the costs of acting are. And here's a little example of that, which hopefully will work.
Our president must decide if he'll sign a UN climate treaty that could increase the cost of gasoline by 50 cents a gallon and raise electricity and natural gas prices by 25 to 50%.
The cost of action is really easy for people to illustrate. And whether those numbers are accurate or not, and they're probably not, right? Because you can do the study in lots of different ways, right? Showing on a TV commercial, gas is going to go from 120 to 170. It's going to be this huge jump, right? this ad in 1997, along with the rest of the lobbying campaign, worked. Right? The US did not sign the Kyoto Protocol, and that was the point of ads like this, showing the cost of acting and ignoring the cost of, or the damages that would accrue from not acting. So people are going to be out there saying, this is what it's going to, these are all the harms. Every time you take a step to deal with climate change, this is all of the bad things that happen, right? So what we've been trying to do is try to give the opposite point of view, right? Okay, there are expenses, there are maybe losses in income in certain sectors of the economy. There are also good things that happen. And we can quantify those and try to provide a kind of fairer comparison, provide the data so people can make a fairer comparison, that is, of the costs versus the benefits. And so we've been focusing on these that are described up there: human health, labor productivity, crop yields, and the economic valuation of all of those things. I'm not going to talk too much about the agricultural ones today. I'm going to really focus on the health, just briefly mention the labor productivity. But one of the things that we've really placed an emphasis on is looking at when something like health or labor is affected. We don't really care about the physical pathway. We just care that it's affected. And when you decarbonize and try to deal with climate change, amongst other things, is phasing out fossil fuels. That's not the only thing, right? You would deal with things like cook stoves, agricultural waste burning, other things that affect both climate and air pollution, methane, et cetera. You tend to have a big effect on air pollution for the majority of actions that deal with climate change, right? Planting trees doesn't necessarily have a big effect, but right, getting rid of, changing vehicles from internal combustion to electric, for example, gets rid of all the tailpipe air pollution, right? So whether that's your point or not, it's going to happen even if it's a climate policy. So we're going to try to include that. And the big idea here is that while people opposed to action have done a really good job of making the costs apparent to the consumer by things like that ad, right? What we want to do is make the benefits, which are really spread out in space and time, make those more readily apparent to people who might be interested. Right? So that's the idea. That's the overall goal: make chronic, diffuse problems of how health is affected by both air pollution and climate change, how labor is affected, how the economy is affected, make these more tangible to people. So I'm going to talk mostly about two different studies that we've published on this topic. One came out a few years ago, and there's a lot of my graduate students and undergraduate researchers on here, so I acknowledge all of their help on this presentation. This was one that looked at the United States, and we tried to look at the effects of decarbonization policies in this country and see what would happen and provide data in a useful way. And so I'm going to show you a few different kind of highlights, in my opinion, of what we found. Here's an example where I'm illustrating at the state level, obviously, on the left 2030 and on the right 2070, and this is putting in place very strict decarbonization policies starting in 2020, right, and then running out into the future. And so what you can see is the avoided deaths are particularly large in the Northeast, right, the Ohio River Valley running from Illinois up to New York, and that's where we have the bulk of, say, our coal-fired power plants that are still running in the United States. In California, it's much more motor vehicles. In other parts of the country, like the Mountain West, you look at a state like Wyoming or Montana, not that much pollution, right? So you can reduce it a little bit. It's beneficial, but the values are pretty small. They vary a lot from place to place. This is particulate matter, right? Fine particulate matter, 2.5 microns or smaller. Here is ozone, and the spatial distribution is in a broad sense somewhat similar, partially because this one is shown in terms of totals, and so it's got population included. There's a lot more people in California than there are in, say, Nevada. But it's a little bit different, and ozone is photochemically produced by sunlight in the presence of various pollutants, and so this one actually strays a little bit more down towards places like Florida and Texas, where you've got more sun, and doesn't focus so much on the Northeast. But the idea is that, different parts of the country will see different benefits, and we can quantify all of those. In our paper, we also quantify city level for some of the bigger metropolitan areas, which you can do for air pollution. One of the things, I don't want to go into all of the different scenarios, but we looked at a whole bunch of different scenarios from IPCC world of doing these large-scale possible futures. And the only point I really want to make here is that while there are a few cases where, in these cases, the total number of deaths increase largely because of population, the actual air pollution exposure stays about constant. But that's a worst case scenario, as we don't make much improvement in the United States. Under best case scenarios, any of those low ones, right, particulate matter on the left drops by more than 3/4, and ozone we kind of get rid of. Ozone has a threshold that's fairly high for our epidemiological understanding of when there is increased risk of death from ozone exposure. And so that one we can get down to essentially zero. This is pretty profound potential improvements. Now I want to turn to heat. And heat, I don't have any change whatsoever in 2030, so I'm not going to show you the same map because, again, right, it just takes a long time for the climate system to respond. We see statistically no significant results whatsoever through 2050. Right? It takes at least 30 years before anything shows up across these scenarios. But by the time you get to 2070, right, you're starting to get to big benefits. With, again, a particular regional pattern, which now doesn't look exactly like either the pattern for PM or for ozone. As a function of time, right, none of these say we've brought the deaths related to environmental exposure down, not even towards zero, but we haven't brought them down at all. What we've done is mitigate how bad they are. But under a worst case scenario, right, the temperatures rise enormously, the planet gets really hot, including our country, lots of people die, and under a best case scenario, it still keeps getting warm. Right? And that's just the truth of it. There's so much inertia in the carbon system and the climate system that we are not going to turn the world to getting colder for many, many, many decades, probably not throughout this century. So we're never going to get it decreasing, but we can still make inroads, right? Acting still provides us, like the uncertainty is shown by these black bars here, and you can see that as you get out into future times, you start to get a difference between scenarios. That really high extreme one, shows up earlier, but for most cases, it really does take a long time. This kind of tries to put them all together in one of the ways that I think is a little bit more interesting. Where on the left, it's in 2030, and which is the leading cause amongst these three environmental exposure factors. And in much of the country, right, PM, the darker blue, is the most important, but ozone is important and PM less important up on the high mountain states where you have a lot of ozone. I mean, if you've been out to places like Denver and Salt Lake City and such, that's now where we have ozone problems in the United States, and in places like Florida, North Carolina and such, places in the southeast where there's a lot of sunlight, right? As you go out to 2070, heat starts to take over in parts of the country. And so heat never becomes as big at least by 2070, it doesn't become as big at the national scale as PM or even as ozone, but it does become the most important thing in some states. And part of the reason it becomes so important in places like the Pacific Northwest, right? You may remember that just a couple of years ago, there was this heat dome in the Pacific Northwest, right? And lots of people died in places like Seattle and Vancouver. Right? And those are places, it's really a question of acclimatization and adaptation. People are not used to it being hot there. A lot of people don't have air conditioning, and it just hadn't been needed there. So the temperatures that were in Seattle and killed lots of people a couple of years ago would be routine in a place like Atlanta or Phoenix, right? But they kill a lot of people up north. And so there's this interesting pattern where it's actually the cooler parts of the country end up being more sensitive for health. This one shows, and I'm going to return to this in a second, right? This one shows labor losses And the upper panel is due to air pollution. What am I, I'm missing something here on, okay, one is days per year and one is days per year per million people. The upper one is air pollution and the lower one is heat. They're both 2070. And what's different here is that the reason I really wanted to show this was that labor is the opposite spatial pattern of health, right? And for health, we find much more susceptibility up in the north, where people are not used to it being hot, whereas people are better adjusted in the south. And so there's this dipole across the country. When it comes to labor, what we're really seeing is that this is people who are working primarily outdoors in heavy labor, things like construction and agriculture, where you cannot have air conditioning. Right? And these are much more sensitive in southern states. So you have a real difference in the relative importance of the health impacts and the labor impacts depending on where you go. And so we have limited programming skills in non-scientific things, but we do try. And one of the things we did was make an online interactive website where anybody could go and look through all of our results. And I'm never sure that, like my limited programming skills, that my internet would work when I'm speaking somewhere. So I took a little screen recording of me using this. And for example, you can look at the scenario, you can choose the years you want, and there's all kinds of impacts in there, right? Restricted activity days, hospital exposures, all kinds of morbidity and mortality. You put your cursor over any state, and it will give you, for example, ozone on the left and PM on the right. So for California, they're similar. For Florida, when I look at these two, ozone is actually much more important. When I look at New York, right, PM is much, much more important than ozone. And so you've got real differences depending on where in the country you might be from or interested in. Now, if I switch here, there's lots of stuff in there, agriculture, morbidity effects. I've switched to heat exposure, right? And now the deaths in California are far less from heat than they are from air pollution. But up north, like in Minnesota here, I find actually heat is more important than air pollution. So again, depending on where you are in the country, you might have something that's more of interest to the place where you live. And here's the last two that I just showed a map of, work loss days. And so if you are interested in air pollution on the left and heat on the right, and you look at somewhere like New York, right, 700,000 days lost due to air pollution, and just a few thousand due to heat. Well, it's not so hot in New York, even in the summer, whereas in Texas, 400,000 or so due to air pollution and 2.2 million. Right, so the idea being that hopefully places like Texas, which might not really want to strongly move towards getting rid of fossil fuels, right? That might be the last thing in Texas amongst much of the industry. But the construction industry might not really like losing, 2.2 million workdays because of heat exposure, and there's really not much you can do about that other than to mitigate climate change. Right? There is a lot of adaptation you can do for health, not so much for labor. And there's a lot of places in, for example, California and Texas, agricultural workers already have to get up, say, in the middle of the night and work with headlamps because it's just too hot during the day. So there are limits. What we did with all of these data was, despite our programming skills being pretty limited, we did have the software to extract numbers for any state that wanted it. And we were able to work with some congressional committees. And they liked this. And so I was quite pleased that somebody was actually saying, these local data are making this problem real to us. And the House Oversight Committee had a hearing on climate and health and how these affected Americans, and then released a bunch of reports drawing from our data for individual states, which were then the kind of thing that, say, a local newspaper, this is from the San Francisco paper, picked up the story about California. It was one of the New York papers picking up the report about the state of New York, a Florida paper picking up about Florida. Right, so in my experience, we've long done global modeling. Everything is big scale. Results are at big scale, and it's hard for people to relate to that. And this is kind of a tangible effort to move towards local scales and make this diffuse problem real to people. Going back to the big scale, one other thing that we can conclude here is this shows the benefits of the morbidity, agriculture, and avoided mortality, which the avoided mortality dominate the monetization of these benefits. But it shows in blue the benefits due to reduced air pollution, and in red the benefits due to avoided climate change. And these are compared with the cost of the energy transition required in the United States. And what you can see is, if you look at the red, it essentially echoes that conclusion we've seen in the Stern Review and the OECD, right? In the long run, the cost or the benefits of acting outweigh the costs of acting, right? That line goes over the 1-to-1. But you don't actually have to wait till the end of the century to come out ahead if you include air pollution. If you include air pollution, since as soon as you start to get rid of fossil fuel burning, right, you get benefits in the very first decade that you act. And these benefits dramatically outweigh the cost of the transition. So this is the kind of thing, the blue part, that the EPA tries to do when they evaluate rules, right? They use software to it's a mandatory thing from the government that they have to do a benefit cost analysis, but then they don't include climate directly. And then the people that do climate tend to not include air pollution. So the idea here was to put them both on the same page. And just to summarize that from the US, right, the idea was that the benefits to health, labor, and crops are primarily from air pollution in the near term. In the long term, we get a lot from climate, but it really does take a while. And then just last month, again, several of my students and some researchers, Yu Chong from Shandong University now in China, helped us do a similar study in expanding the work beyond the United States to South Asia and to China. And we wanted to see if the results would be similar there. And I won't go into all the details of the modeling, but for anybody who's interested, we used a whole variety of models to characterize uncertainties and such. And we were able to look at, on the left column, the mortalities from fine particulate matter exposure, and on the right column, the mortalities from heat exposure. And they don't have the same scale, right? In a place like China, it's up in the millions currently from air pollution, and it's down more like 100,000 from heat, right? But over time, they become closer in most countries as the exposures from heat rise, and in some places, at least, the exposures from air pollution decrease. Now, it turns out that this is a pretty complicated one. I'm just going to skip one ahead here. And what's going on here, this shows a kind of a snapshot at 2050 on the left column and 2090 on the right column. I haven't quite worked that out, have I? All right, anyway, I'll just say, because I don't know how exactly to point there. What it's showing is that, in these scenarios, there's a lot of complexity going on because you can't just project an amount of emissions without having some idea of, say, how many people there will be in a particular country. And we know that the population is not static, right? So what we've tried to look at is these different bars here show that we have both difference in exposure, that's PM in red. We have difference in population, which is in green. We have difference in baseline healthcare and vulnerability, which is in blue. And we have orange is age. And so sometimes you get the kind of confusing result that under a sustainable scenario, people are better off, right? They have healthier diets, they have better healthcare, they live longer. But since they live longer, there are more old people around when they have a very high risk of respiratory problems from, say, breathing particulate matter. And so the average lifespan is more than a decade longer in the sustainable scenarios than it is in the reference scenarios in many developing countries. And so you sometimes get more people dying, but for a good reason, as it were, that they haven't died earlier from something else. More people die from air pollution, but they die much later. When you look at the red bars, you can see that there's very large impacts from improved air quality. In the upper row is a sustainable scenario, 1.5 degree, or 2 degrees rather. And you have much reduced exposure, particularly in India and China, from particulate matter, but you do have these aging populations, and the reduced exposure can offset most of that. So for example, in China, you get almost no change, But if you didn't reduce the PM exposure, you would have had a massive increase. And you can see that a little bit in the bottom one, which doesn't reduce the exposure. When you go to something like health, you can see the difference between the 2-degree scenario on top and the kind of more like 4 to 5 degree scenario on the bottom is no longer opposite sign, but the increased exposure, which is the red one again, is much larger under the reference case, and it's muted, but it doesn't go away under the upper one. You can also see that the black dots are the sum, and the black line gives the uncertainty range, and there's a lot more uncertainty in the climate impact via heat exposure than there is in the impact of these policies via particulate matter. Right? We've got really good epidemiological studies on particulate matter exposure, and the models pretty much tell us the exact same thing happens to particulate matter when we run different models. When we look at the epidemiological data for heat, high uncertainties, and the models diverge when we project exactly what the temperature change will be in a particular place. So there's a lot more uncertainty in that one than there is in the former. One of the reasons that I think we really were excited to get results for China is because China is the world's largest emitter, right? And if China does not go along and decide that in their own interest, they really need to move as aggressively as possible on reducing climate change, then the rest of us, we have somewhat limited leverage, right? We really need China to be advancing. And so one of the things that we've done has worked with our Chinese colleagues and have actually shown things like China cannot meet its own air quality goals without dealing with climate change. So they can make the argument all they like that they're not responsible for as much as the United States, which is very fair, right? We started emitting long, long before, but it's in their own interest. And in fact, they can't meet their goals without getting this twin benefit of decarbonizing, which reduces air pollution at the same time. So what we found for China was that, like for the US, the health benefits alone are more than enough to outweigh the costs of the energy transition. We found that in the uncertainty range in India encompassed both. They're large enough to fully offset it, and they're large enough to partially offset it. Unlike for the United States, where eventually, since our air becomes so clean under a sustainable scenario, heat dominates. That doesn't happen in the Asian countries, but it becomes much more important than it is today. One thing that we're working on now, which is just something I'm kind of excited about, is trying to compare some of the heat studies with work that the Global Burden of Disease Project has done recently. And what we find is, we have a difference in absolute because we have used all cause, where heat can impact anything whatsoever, and the Global Burden of Disease has used specific cardiovascular and respiratory diseases and metabolic diseases. So we'd expect ours to be large, but we also find a big difference in the response to changes as a function of time. And so what we hope to do is explore the difference between theirs and ours and maybe be able to tease out something about how people are adapting to change over time. And maybe that's one of the reasons they, using empirical data, are showing less of an increase as the planet warms. So I would conclude by saying that we have kind of some good news and bad news. And the bad news is when we talk to people, like climate change is so important because there's this major health issue, right? Well, there's a major health issue, but unfortunately, by tackling climate change, you're going to hardly affect that major health issue for the next several decades. You will eventually make all the difference in the world. In 2100, we will have a very different health community, a different planet, and a different environment, if we act now or don't. But for the rest of this half of the century, very little happens. But the good news is that actually people prioritize things, psychologically, stuff that happens more quickly, right? And when you think about air quality, it's much larger than we thought if you use some of these newer epidemiological studies like this global exposure mortality model rather than the global burden of disease or WHO. And most come from our own actions. I didn't really go into that, but at least for a big country like the US or China, most of these benefits are under your control, whereas most of the benefits from avoided heat exposure, come from global cooperation. right? And if the US does everything possible to reduce our carbon footprint, but nobody else does, we don't get the heat benefits. But no matter what everybody else does, we get the air quality, right? And most of these are related to health, which tends to overwhelm anything like the reduced number of people going to the hospital, the reduced labor productivity. Those things are useful, but it's health that dominates the economic valuation. And I think that one of the ways we can see why this is hopefully at least a more compelling message is there was a study by the Chilean government, their Ministry of Environment, the equivalent of Ministry of Environment, and they asked people what were the most relevant problems. And people, literally, and this is a picture of Santiago over there, right? It's like LA trapped in a valley. You can see the air pollution. It really matters to people. They know that this is important. And when you look at down this list, right, climate came out with 1% of the population saying this was most important. I especially like this because street dogs are rated as more important than climate change, right? So there's a ways to go trying to make the argument just by climate, especially in developing countries. I'm going to end there, and here is, as we heard before, the QR code for you to take a picture of. Thanks.
We have about 15 minutes for questions and answers.
One, I would be down if I didn't emphasize the importance of the survey as someone who worked for Becky. But my question for you is, one of the big issues with decarbonization efforts is the extraction of minerals and precious metals and things like that for batteries, for solar panels, and for other clean energy initiatives. Right. And I know you have to control for so many factors when you're modeling out decades into the future, but I was wondering if that was something that you're able to take into account. Because the cost of decarbonization is not just financial, but those extraction efforts often have a negative impact on the environment themselves, and can obviously negatively impact health and climate change in their own way, even if it is in the name of solar panels for clean energy.
Right. Yeah, thank you. That's a great question. And so one of my postdocs is hard at work on a paper on this topic. And one of the things that we're finding that's actually really interesting is there's a lot of discussion about, there's this big environmental footprint. You've got to dig lithium out of the ground, and that's how you make these batteries. I mean, have you thought about that? There's this footprint. Well, there's a big footprint for getting oil out of the ground, right? And if you look at an internal combustion engine, right, that has a long life cycle chain too. You think of something like, the Exxon Valdez or Deepwater Horizon. This is not a small thing. People live near oil and gas extraction sites, get a lot of hydrocarbons blowing their way, cancers. So he's trying to look at a consistent valuation. Clearly, the use of the product, right, an EV versus an internal combustion engine, for example, or renewables with battery storage versus fossil fuel-fired power plant, right? The use is better. But if you go through the whole life cycle, so far what we're seeing is that the clean solutions are still much better from an air point of view, and that they're also substantially better from water. And lithium mining, again, uses a lot of water, but like when I looked at these numbers, the first time I looked at that, especially natural gas, oh my God, that used a lot of water, right? Extracting from fracking especially, the water footprint of fossil fuels is enormous. So I think we are going to see that you really still come out ahead with clean energy, right? Which doesn't mean we don't have to think about it and have proper recycling and disposal at the end of the lifetime and such, but I think we'll come out ahead.
So my question is thinking about those maps of the United States and the differential impacts of some of these actions, and I don't know if the costs are the same to all the states to take some of the action, but what was some of the response as far as like, decisions need to be made at the state level versus this is a federal thing, even though the benefits
right.
and potentially the costs may be different across different states?
Yeah, so I think that's you. What we found was still in both the House of Representatives and the Senate, right, that the representatives are the ones making the federal policy, but they're still very interested in knowing what happens back at home in their constituents. So they felt that this was helpful for them to be on board at the federal level because their constituents care about what happens at the state level. The cost is a different, we haven't gone into that as much in ours, and that one can be quite challenging to work out because often, other than Texas, right, the grids, for example, are not like located within states, right? And the only way to make things like lots of renewables work on the grid is have interstate transmission lines and such. So I don't think I guess the answer is it's not so easy to do that. It's easier to quantify the benefits within the states than to quantify the expenses because many of them are not clearly in a given state. Right? There's a lot of different places, different ways you could arrange the grid. And if you say transition the whole country to electric vehicles, right? Well, that doesn't guarantee where the new plants are built, right? That could be anywhere. So that's a hard one. But they liked the idea that you could tell their own state's constituents something that would be benefit back home. And the fact that you could, since you had a whole variety of benefits, you could find something that actually was substantive in your state, almost no matter where you were in the country.
Just following up on that, I'm curious, the tool you presented is very cool.
Thanks.
It strikes me, though, that there's two very different types of impacts. The health impacts, which are not market impacts.
Right.
And then you have like lost labor productivity, and agricultural impacts, which are market impacts. From your interactions with policymakers and media and so on, were they still focusing on the dominant impacts, which were the health impacts, or was it more actually on the market impacts? Because to a policymaker, it's very different.
Yes. So I would say most are kind of focused on the bigger number, which tends to be the mortality, right? Which tends to dwarf everything else. But there are some that still say, oh, that's not real money, and I'm not really interested in that. And so I didn't highlight that, but that's one of the nice things about having that in the tool is you can go look at all the ones that are market. And for some people, that really did seem like, okay, these are ones I understand. This isn't like a statistical thing. This is how much is happening in construction and agriculture in my state. And this is how much we're spending for, we have things like hospital visits and emergency room visits. And so I would say it's a minority, but there was a, non-negligible group, minority group that really did value the market ones more than the non-market ones. Yeah. Oh, over here.
Okay. My question is there a policy you would like the United States to adopt to increase incentives for regular citizens to make environmentally friendly choices?
A policy that I would like the U.S. to
adopt to increase the incentives for individuals to make environmentally friendly choices?
Oh, to increase the ability of individuals? Yeah. Okay. I think that actually, so, usually I talk about things like, look how much it's warming, and we can't do very much about it. It's all very kind of like terrible, right? I think that actually we have made some tremendous policies in the past couple years. And so I think, one of the things, I don't know what it's like in Atlanta, but one of the things that it's like, for example, where I live in North Carolina, is you buy your electricity from the monopoly provider or you don't have electricity, right? You have no choice whatsoever. And so there, I don't think, there really is a way to easily allow individuals, unless you dismantle the monopoly structure, which doesn't look at all likely, to have individuals make sort of any sort of choices. So what I think the government is doing is, for example, the EPA has published regulations that would apply to all power plants in the nation. And I think that's really the way to go because we don't necessarily have the power to make personal choice. When it gets to things like personal choices, then you have things like, motor vehicles I can choose, but I can only choose practically to buy an electric car rather than an internal combustion engine if there's places to charge it, right? So there I think the government's policies of things like using the infrastructure bill to support charging infrastructure is really key. And I think that they strangely gave a lot of money and have built hardly anything with it yet. So I'm hopeful that will change. I think they have one charger installed or something. But they have a lot of money. And I think that's a key thing, right? The government doesn't need to provide people electric vehicles or even necessarily mandate that companies sell them, but they have to give consumers the power to choose them, and that only makes sense if there's infrastructure, right? If you can charge them. And so they could make zoning regulations that say also when you put in buildings, you have to have chargers in them, right? All of those kind of the underlying systemic things is where I think the government needs to step in. I guess the last one I would say is things like composting. When I moved, I used to live in New York and we had composting from the city, and when I moved down to North Carolina, like, there's nowhere to put it, right? And what am I going to do? Set up my own like industrial composting or something, right? This was just not going to happen. So I think there are very specific things that government can do to enable people to make lifestyle choices like composting, using non-fossil products. And then there are other things where, people like you in this room can hopefully educate people about making dietary choices, which I don't think is necessarily the government's role. They might help, right? Educational campaigns like telling people that smoking is not good for you, too much consumption of red meat. If that's not good for you, they should be telling people. But I think people should still have choice, and what they need is much more education from, say, the medical profession rather than from the government. That's my 2 cents on that.
Mine's a softball because we talked about this just an hour ago, but I found it really helpful. Can you share with folks like what you're optimistic about? What brings you optimism in what you've seen recently?
I guess one thing that brings me optimism is when I go in, like I did last month, to teach a new class of undergraduates, and I start talking to them and I say, by the way, has anybody ever heard of, this thing about climate change? And every hand goes up, and I think, wow, this is amazing, right? When I was 20, right, I knew something about, I don't know, baseball and Dungeons and Dragons or something, right? And they know all of this cool stuff about climate change. They really, they come in already understanding this is really a key thing. Whether I'm going into economics or public policy or whatever, I really want to make a difference. And I think that's huge. I mean, that gives me optimism for the long term. Right? For the short term, I think there's still a lot of things that are super challenging. And I think we've seen, like I mentioned before, right, the US made this big change. Europe, partially in response to the invasion of Ukraine, shifting. China really shifting. But that leaves lots of the world behind, and that's still going to be slow. And how do you get people, everywhere to say stop buying gasoline, right? Maybe the price will start dropping after we go to electric vehicles, and there'll be this supply and demand imbalance. And how will you get the last groups? How will you get Irans and Venezuelas and places that are not even necessarily part of the system? So there's a lot of challenge, but I think in the long run, the young people it's just such a sea change from where it was, like when my undergrad days to current undergrad days. I think that's really encouraging. Okay.
You have shown so far, not many countries are doing anything. We're going through that business as usual structure. Kind of the, not very optimistic. So what would be the last resort? Do you think like the crazy geoengineering measures would be the last resort? We have to do that?
Well, I'm not sure I know the answer to this one, but I mean, I could envision a case where the damages start to become so large. I mean, generally, I think the geoengineering is a terrible idea, but it could be, right, like, was it Churchill that said democracy is the worst except for everything else, right? This could be the worst thing except for not doing anything and just allowing everything to fall apart, right, if we really don't get our emissions under control. So I'm all in favor of as much carbon dioxide removal as we can sustainably manage, which requires a lot of land and water potentially, right? So we need areas to plant trees. We need to manage the soil carbon. So that's kind of net negative. CO2, I think that stuff is all good. But I could envision a time when we have to deploy kind of more outrageous things. It would be, what I'd worry is something will go wrong that we haven't thought about, right? And, it won't prevent acidification of the oceans. It will lower sunlight if it's one of those kind of things, which will affect ecosystems in unexpected ways. It could easily cause there to be, floods in Pakistan the year after we start, which they blame on India and start a war, right? And who's to say, or demand compensation, right? I mean, there were huge floods in Pakistan a couple of years ago, right? And they weren't attributable to geoengineering. But once we start geoengineering, if we were to, then everybody would say, oh, whoever's doing this is now responsible for everything bad that happens. And it could promote all kinds of conflict. So I would say really, really, really last resort. But it could be, that we get to that, right? When the planet's catching on fire all the time and we're like, we can't manage this. Or methane emissions from wetlands are going up so quickly because of climate change that we're starting to get positive feedbacks that are outrunning our ability to keep up, right? Then might be the only choice. I hope not.
Any other questions before we wrap up? Okay, let's give a round of applause to the crew.
Thank you all.
Thank you so much for coming down here and meet with us. You have more meetings to do today.
Yes.
Thank you all for coming.